Hey, what's up guys, welcome back to Eureka, and in this video we'll be learning the distance and midpoint formula. So to begin with, let me draw my coordinate axes, x and y, and I'll draw two vectors, vector A like that and vector B like that. So this is A, this is B. And the goal in this video, there are two goals. We need to find the distance between the two terminal points, and then the second one is to find the midpoint. How do you find a distance? Let me draw something like this. We want to find this red line, right? Let me draw this yellow line, those lines so that we can refer to them when needed. And then we clearly see that, we see that this is a right angle. Yeah? So all we need to do is to find this length, the length from this point to this point, I denote by L, and then the length from this red point to that red point, which I'll denote by L, L vertical, L horizontal. Okay? That means the distance, which is what we need to find, the distance squared is equal to LV squared plus LH squared. Now, what is LV and LH? Notice that this blue line is the y component of the vector A, right? And then, let me undo. And then this blue line is the y component of vector B, right? So if we find the differences between those two lengths, we'll get L sub V. Let's do it. So L sub V is equal to the distance between A sub y and B sub y, right? The same argument can be made for L sub h. So L sub h is equal to, let's see, it is B sub x minus A sub x. Now you might be asking, why is the formula kind of different? Because one of them is A minus B, other one is B minus A. For the final result, it won't matter, but for the lengths, it's because for LH, B has a longer x component than A, right? While A has a longer y component than B. That means we need to subtract the bigger subtracting the small, right? That's why I did it in this order. But for the distance, it doesn't matter because I'll be squaring them anyways. Now, plugging in the formula gives us d squared is equal to ay minus by all squared plus bx minus ax all squared. That means the distance is equal to the square root of all this. Now, let me make this look more like the formula in the book, which is written like d is equal to square root of b sub x minus a sub x squared plus b sub y minus a sub y squared. Notice that I switched the order. This, I switched it to that. Different order, as I said, doesn't matter because after we subtract, we'll be squaring it. And squaring it will sort of remove any negatives from this quantity. Now let's move on to the midpoint formula. Let's say I have my coordinate axis, I have x and y, and my center will be O. And then I have two vectors. I have vector A like this and vector B like that. This is A and this is B. Now let me draw some other vectors so I can prove this property. Let me move OB up. So I have a vector AD. Let me name this point D. And then I'll move the same thing. I'll move OA to the right. I'll get a new vector, which is BD. Now I will join the, which color? Let's see. I will join the diagonal, which is OD. And I want to find the midpoint of A and B, right? So I'll also draw this segment AB or vector AB or BA, doesn't matter. So basically what we need to find is this vector OM. I'll label this point M. Now let's put some points down. For example, this point right here is x1, y1, and this point is x2, y2. We need to find this point over here. Not this point. We need to find the vector OM, but M is denoted by a point as well, right? So let's see how we can do this. We know that from our vector addition, vector OA plus vector OB, so we have OA plus OB, this is equal to OD, right? We imagine moving OB up, so it's AD. AD is equal to OB in vectors, right? So that means OA plus OB is equal to OD. And we also know that OD is equal to 2OM, right? You scale OM twice because this figure that I have here is a parallelogram, right? Opposite sides are parallel and they are congruent as well, makes this quadrilateral a parallelogram. Solving for OM gives us OM is equal to OA plus OB over 2. Now, what is OA? We know what it is, right? Which is equal to, let's see, we have x1I, that's not an I, this is an I, plus y1j, right? Plus OB is x2I plus y2j, all this over 2. Now let's group all the i's and j's together. So we have x1 plus x2 I plus y1 plus y2 j all over 2. Now let's bring the 2 inside. Basically distribute. So we have x1 plus x2 over 2 all I plus y1 plus y2 all over 2. This all of it j. So this is OM. We have found, that's not it, we have found the midpoint. In exams, of course, you don't need to do this every single time. This is just a proof. But what you need to do is, for the x component of the midpoint, you take the x components of the 2 points, which is x1 and x2, add them up, divide by 2. That's your x component of the midpoint. Same thing for the y component. Anyways, that should cover everything for this video. I hope you guys understood, and as always, easy.